Hello, my name is Takaya Ishman from Grant University. I'll talk about subjective sensation and force characteristics of electrical muscle stimulation due to waveform changes. This is the table of contents. First, I'll talk about study background. Recently, there are many studies using electrical muscle stimulation (EMS) as haptic feedback. For example, there are studies that control the hand shapes to teach the performance of musical instruments like this, and studies that are used as haptic feedback in AR and VR. Also, there are many other studies about haptic using EMS. Though there are many studies about EMS in using EMS as haptic feedback, the following two important factors have not yet been quantitatively verified. First is examination of waveforms other than pulse waves. Second is the relationship between physically exerted force by EMS and force felt by human. In this study, we will quantitatively verify these two factors. Why we research waveforms? It is because most studies about EMS use pulse wave. However, in the medical field where EMS was originally used, various waveforms such as sine waves and combination of pulse waves and sine waves and high frequency waves are being studied in addition to pulse waves. So we should consider waveforms other than pulse waves, even in haptic feedback. Why we research the relationship? It is because we should know how users feel about force by EMS. As you know, there are differences between the physical volume of input signals and human sensation. The doubled input volume does not induce doubled sound for human. As you know, this is Weber-Hefner's law. As with sound, there is a high possibility of a difference between the exerted force by EMS and the force that human feels. This leads to a misunderstanding of the design content, because the designer cannot present the intended force to the user. Next is evolution experiment of input waveforms. We examine waveforms suitable for EMS. This time, we use pulse wave, sine wave, sawtooth wave, and dual sawtooth wave. Specifically, we use a total of 9 types of pulse waves, one with a frequency of 20 to 80 Hz, and a pulse width of 0.6 milliseconds, and one with a pulse width of 0.2 to 1.0 milliseconds, and a frequency of 50 Hz. For waveforms other than pulse waves, we set the integral values to be the same with difference to pulse waves with a frequency of 50 Hz and a pulse width of 0.6 milliseconds. Specifically, the sine waves double the pulse width. We use 2 types of sawtooth waves and dual sawtooth waves, one in which pulse width and amplitudes are multiplied by √2, and the other in which the amplitude is the same and the pulse width is doubled. Therefore, since there are a total of 5 types of waveforms other than pulse waves, we consider a total of 14 types of waveforms, including pulse waves. Next, I explain the experiment. There were a total of 7 participants, with an average age of 23.1 years, and a standard deviation of 0.6. We place the electrodes at position that stimulates the extensor muscle of the index finger, as shown in figure. We stimulate for 5 seconds for each waveform, and participants evaluate the 3 items of electrical feeling, pain, and discomfort, on a 5-point Likert scale. At the same time, we recorded the presentation force and voltage. First, we compare the pulse waves with other waves. The vertical axis of the figure is the evolution value, and the larger the evolution value, the greater the feeling. We show discomfort as orange, pain as blue, and electrical feeling as green. The asterisk in the figure indicates combination with significant difference at significant level of 5%. We can see that sawtooth wave 2 and reverse sawtooth wave 2 have significantly lower Z sensations than the pulse waves. This is because the voltage changes slowly, as shown in the above figure. So it is possible that the feeling of electricity, pain, and discomfort have decreased. Next, we focus on voltage and presentation force. The left axis shows the voltage and the right axis shows the presentation force. Orange is the voltage and blue is the presentation force. Sawtooth wave 2 and reverse sawtooth wave 2, which had less electrical feeling, pain, and discomfort in the previous result, have less presentation force. The reason for this may be that the stimulation time with a large voltage is short. The above figure shows that the stimulation time with large voltage is shorter than that of the waveforms. In addition, the presentation force is also small for sine waves that are stimulated with a large voltage for a short time. From this, we consider it necessary to continue stimulating with a certain high voltage to exert sufficient presentation force. We also found that sawtooth wave 2 and reverse sawtooth wave 2 are not suitable for tactile feedback because they have smaller C sensations but less presentation force. Next, let's look at the result when we change the frequency and pulse width. On the pulse wave, the vertical axis is the evolution value, the horizontal axis is the pulse width and frequency. From the result, we found that the larger the pulse width, the greater the thrill and desire sensations, and the thrill sensations do not change significantly at frequency. Next, we focus on voltage and presentation force. The left axis shows the voltage and the right axis shows the presentation force. From the result, we found that the larger the pulse width, the greater the presentation force, and the higher the frequency, the greater the presentation force. Suitable for tactile feedback by EMS is waveform that does not cause discomfort, pain, or electrical sensation, and can exert sufficient force. Waveforms such as sine waves, sawtooth waves, and reverse sawtooth waves that are stimulated with a high voltage for a short time are not considered appropriate because the presentation power is weakened. Therefore, when we examined appropriate conditions for pulse waves, we thought that the frequency of 50 to 80 Hz and the pulse width of about 0.6 milliseconds would be appropriate. Next is evolution experiment of force sensation by EMS. We examine force sensation by EMS. We evaluated the relationship between exerted force by EMS and force felt by the human. We investigated the point of subjective equality (PSE) between force by EMS and force by a motor using the method of constant stimuli. For that purpose, next, I explained the experiment. There were a total of 10 participants with an average age of 23.2 years and a standard deviation of 0.8. We place the electrodes at position that simulates the tensor muscle of the index finger. Participants compare the constant stimuli and the comparative stimuli and answer which is larger. Constant stimuli is 0.3 Newton forced by EMS. Comparative stimuli are 0.1 to 1.0 Newton forced by motor. First, we presented constant stimuli or comparative stimuli for 3 seconds. After that, we presented the other stimulus for 3 seconds. We only changed comparative stimulus. We conduct 20 trials for each combinations. We presented in random order to eliminate the order effect. The vertical axis of the figure is probability of determining that the comparative stimulus is larger. The horizontal axis shows presentation force by motor. The solid line is the result of fitting with the cumulative distribution functions. The point where the probability is 0.5 is PSE. Participants cannot determine which is larger at that point. From the result, PSE is 0.6 Newton. So, when the force by EMS is 0.3 Newton, PSE with the force by the motor is 0.6 Newton. In other words, participants felt about twice as large as the force by a motor. Why participants subjectively felt twice as large as the force by the motor? Normally, only afferent nerves respond to and perceive external stimuli. However, EMS may stimulate both efferent and afferent nerves at the same time. Conclusions. From evolution experiment of input waveforms, pulse wave is suitable for EMS because it can suppress the electricity, pain, and discomfort. In addition, frequency of 50 to 80 Hz and pulse width of about 0.6 milliseconds is suitable. From evolution experiment of force sensation by EMS, the force felt by the user is likely to be almost twice greater than we intended. When the force by EMS is 0.3 Newton, PSE with the force by the motor is 0.6 Newton. If you have interest in our study, please read our proceedings. Thank you.